Alright, ladies and gentlemen, welcome back. Today I'm going to do something a little bit different for you. I would like to start off by showing you a quick little video of a dilation. I want to show you a short video of an eye, like a close-up on an eyeball. So before I showed it, if anyone's freaked out by a close-up of an eye, you can just kind of turn away for like 30 seconds. So this is a video of an eyeball. Okay, now the light is currently shining on the eye, and they're going to turn the light on and off. What I'd like you guys to do as you watch this is please try to notice right here. Okay, notice the pupil. Okay, here we go. Light's turned off. Notice how it reacts to the light. Here's another one. This next one's a little bit better. Yeah, okay, so what this is known, those of you that have glasses, you've probably had your eyes dilated before, okay? And we're going to talk today at length about what a dilation is and how we can view it in geometry. A dilation takes effect in a lot of different places, but the eye is one place where this really does happen. If anyone here has ever had their eyes dilated, what do they give you when you leave your optometrist? Well, they give you sunglasses. The reason being is that your eyes are very, very large and they can soak in more light. And if you were to happen to look at some very bright light while your eyes are dilated, you would do a lot of damage to them. So that's just a little heads up there. Okay, so what we've got is dilations. So a dilation, D-I-L-A-T-I-O-N. With center C and scale factor K is a transformation that maps every point P in the plane to a point P prime. Okay, we call this prime, kind of like Optimus Prime. There we go. So the following properties are true. If P is not the center point C, then the image point P prime lies on a ray CP. The scale factor K is a positive number such that K equals CP prime over CP, and K cannot equal 1. If we're talking about dilations, the reason that K can equal 1 is because if it was a 1 ratio, it would be the same shape. A dilation has to get bigger or smaller. A dilation is called a reduction if your K, your scale factor K is less than 1 but greater than 0, and it is an enlargement if your K value is greater than 1. Okay. So let's take a look here. Identify the following dilations and find scale factor. Here's the hardest thing. The thing with the apostrophe, okay? So this P prime is known as your, prime. This is the new shape, all right? So this right here, the thing that I'm scribbling in, that's the new shape being formed. Guys, use some common sense here. Do you think this shape is getting smaller or bigger compared to the original? Hopefully you'll notice that it's getting smaller. Since it's getting smaller, we call that a reduction. Okay, so we're labeling it's a reduction. Now, if you want to figure out what your constant K is, okay, because your scale factor is K, like we see up here, K equals CP prime over CP. Now I do want to give you one little heads up. It's not always going to be the letter C and P, okay, like on homework or on group work or whatever. You could have an X and a Y there, but you always want to go from the point, okay, your center point, to your new shape. So in this case, that distance is 3. And then you want to go from your focal point, your center point, all the way out. So that's the 5. So because my K is 3/5, that verifies that I have a reduction, because as long as that scale factor is less than 1, it's a reduction. Okay? So, very good. Now, this was a dilation with a triangle. We can do a dilation with a quadrilateral, all right? So I'm looking at the two letters here, P and P prime. Hopefully you guys notice this is my P prime, so I'm going to color this in. Is this shape getting larger or smaller compared to the original? This time it's getting larger, so this is called an enlargement. Okay? So if I was asked to find my scale factor, CP prime over CP, all right, so we are looking at from C, the center point, all the way out, 12, over C to P is 5. What I'd like you guys to do is, I'd like you to leave it as an improper fraction, okay? I know you could put that in a calculator and get 2.4, but I want you to leave K equals 12 over 5. All right, as we get further along in math, you want to answer more questions with fractions as opposed to decimals. Okay? Very good. All right, so on the back, it says, use the origin as the center and the scale factor of 2. Find the perimeter of the pre-image and the perimeter of the image. Okay. So here is my original image, the x, y, z. All right, so if we want to figure out we know it's a scale factor of 2. So take a look at this. From x to y, we know the distance is 3. How do I know that? Please just count. Okay, 1, 2, 3. And over here from y to z, I'm going 1, 2, 3, 4. So this distance, x, y, z, x, y, z. We know this is 3, we know this is 4. And this is a special shape, it's a right triangle. So I'm trying to find the distance on my third side. I'll call that c. Well, you could use distance formula, I could plug in distance formula, no problem, but because I have a right triangle there, I have a special opportunity to use something called Pythagorean theorem. A squared plus b squared equals c squared. In my conversations with you guys in class, I've kind of heard that you're feeling familiar with this, so here is my a, here's my b, c is always your largest side, so I'm doing 3 squared plus 4 squared equals c squared. I'm going to go ahead and square 3, get 9. Square 4, I get 16. 9 plus 16 is 25. Okay, so here's the hard part. C squared equals 25. What's the opposite of squaring something? Well, we can square root it. The opposite operation is square root it. And we get c equals positive 5. Okay? So, this distance is now 5. They asked me for the perimeter of triangle x, y, z. Well, the perimeter is when you add everything around the outside. Okay? So I've got a 3 plus 4 plus 5. 3 plus 4 is 7, plus 5 is 12 units. We always want to give units. Well, they also want us to give the perimeter of triangle x prime, y prime, and z prime, which is the big one. So we could count down if we really want to. 1, 2, 3, 4, 5, 6. Now, doesn't that make sense? Because think about it. The first one was 3. All right. So now we have a scale factor of x prime. Z prime. So now this is 6. This is, if I do 4 times 2, I'm going to get 8. Do I want to do Pythagorean theorem again here? I'm hoping that you guys are as lazy as I am, because I really don't want to. I already know the first one's 5. So if I want to find a new one, just times it by 2, 10. So my perimeter here would be 6 plus 8 plus 10. 6 plus 8 is 14, plus 10 is 24. Doesn't that make sense? Because think about it, the original one was 12. I'm doubling it, it's now 24. Okay? Definitely a harder problem, but nothing that you can't handle. This is also a very special right triangle. If you have 3, 4, 5's right triangle, you will see that again and again and again, and then again after that, and again after that. Okay. Use the dilation shown to answer the following questions. So is the dilation shown a reduction or enlargement? All right, so over here, this is my primes. So this shape right here, okay, is my new shape being formed. Is that smaller or bigger? Hopefully you guys are cool to see that that's a reduction. Okay. Now the scale factor. Here's a little bit tougher. So I want to find the distance, okay, from my center point to M prime, and then I want to find my distance from my center point all the way out to here. Okay. I could do that. Okay. Or, I'm trying to think of a better way to explain that. We'll show that, okay? There's different tricks you could do to figure this one out. You just got to figure out from here to one of these vertices. So, let's take a look here. Let's go from here to M. Well, the triangle being formed, this is 1, 2, 3 across, and this is 2 going up. Again, I'm with a right triangle, okay? So this is for my M prime. We're going to do 2 squared plus 3 squared equals c squared. 4 plus 9 equals c squared. C squared equals 13. The opposite of squaring something is to square root it, 13. Okay, now I want to do the same thing for my big triangle. So I'm going to count over. And by the way, how am I doing this? I'm just creating a right triangle inside of it. 1, 2, 3, 4, 5, 6, 7 across. And then I'm going up 1, 2, 3, 4, 5. So again, here's my Pythagorean theorem. 7 squared plus 5 squared equals, we'll go c squared again. 49 plus 25 equals c squared. C squared equals, let's see here, 54, 74. Okay. All right. So how do I figure out what my scale factor is? Well, it's from the distance from your center out to your prime. So we're looking at, that's the square root of 13 over the distance from my center to my m, square root of 74. So I'm going to go ahead and grab a calculator. Okay, so on my calculator, I'm going to go ahead and, hope you can see it, there we go. Square root of 13, close it, divided by square root of 74. 0.419, we're going to round it to the nearest hundredth, so 0.42. Okay, which again makes sense because it's a reduction, it's getting smaller. Okay, and finally, what are the coordinates of the vertices of the image? The image is what you are creating. The pre-image is the one before. So the image would be my m prime, q prime, p prime, and n prime. If you're looking for coordinates, I'm literally, here's my 0, 0. I'm counting 1, 2, 3 to the right up to, so it's 3, 2. Q prime is just 2 to the right. I'm not going up or down, so it's just 2, 0. P prime is 3 to the right, 2 down, so that's 3, -2. And then my M prime is 1, 2, 3, 4 to the right, and not up or down at all. Okay? So, quick recap. It's a reduction if your K value is less than 1 but greater than 0. It always has to be positive. And it's an enlargement if it's greater than 1. So it's basically like, the other thing I like to think about is if you take like a flashlight and you would used to do like shadow puppets with your friends when you were young. Your hand is real small, okay, but then the shadow is getting bigger as it goes out. So it's just another thing that dilations kind of reminds you of. Keep up the good work, and as always, good luck. We're all counting on you.